Today's talk, I think, in some ways, probably is a little bit of a conversation almost between the two of us. Our similarities beyond being from Taiwan and liking basketball probably and sort of ends there. So you might just be talking past each other, right? But hopefully, I think the threads are kind of interesting and sort of woven together. If things go horribly wrong, it's all his fault. But I'll let Jenny take it away.
Yeah, okay. Yeah, first, it's my honor to be able to present with Lisu, and then thank you, Lisu, for his kindness to present with me. And so our title is Tatxonavigting Multivariate Design Space Reality, and we will focus on the discussion surrounding the image's meaning, human perception, agent, and language and form. That's the first part. And then, so we live in the age of information, data, model, and simulation. Perception and reality are two sides of the same coin. It often matters more how we interpret, frame, and represent information as a narrative in our understanding of the world. Instead of a singular truth, there are multivariate realities waiting to be uncovered, observed, curated, and narrated. So how do different forms of information and representation influence our perception and decision-making in the design process and further reshape the current reality is the discussion we hope to have today. And so first we start from image and meaning. And so now the information age, we often refer to the computer or digital age, but actually it has started since the beginning of the human history. And the evidence of imaging can be traced back to this cave art like 70,000 years ago. And then, so this is kind of beginning of we think about a human being has a symbolic mind to think in this very graphical way. And then it's kind of as a communication tool. And so maps, and the other maps contains a wealth and of curated information and also serve as a model of the world, and they are representation of the reality and both abstract but also informative. And then they can indirect or direct influence the reality. It depends on how we, the cartographer draw the map, how we define the boundary of different like political space. And then the same information can become completely different when it's being projected in different way. And so the meaning and story might change. Our understanding of the same information can be easily manipulated through the projection. And so what is real or true is not important. The tangible light becomes a new truth to reshape how we engage with the world. So this is like a Chinese version of the world map that is different from the conventional Western version, where China and Asia is in the west, and America and Europe is in the east. And then this kind of perspective varies depending on who the observer is and how we perceive the information.
And to pick up on maybe Julius's earlier session where his artwork and explorations were about kind of what the point of view really is, we're always also commonly reminded of the sort of basically the practice of cartography, and what it started is essentially during the colonial sort of European colonial naval era, as well as the instruments that really oriented us towards the polar north. And what's sort of interesting about this is that about the point of view in which we see something is that you'll also have maps like this of America that are, because of the viewpoint from sort of a naval point of view, that they are locally accurate, but in terms of a larger, kind of broader global view, they're actually grossly inaccurate. And you can see there's actually apparently a channel that cuts parts of, into parts of California in this particular map. But also the interesting discussion is about politics and let's say, in this case, what happens if we flip the world upside down, right, and take our traditional map and look at it from the other direction. But the mapping sort of process goes all even back to John Snow's sort of mapping in terms of epidemiology, the maps of cholera outbreaks in London. And it's also interesting that this sort of geographical mapping technique actually was one of the, I think, earlier examples, predates the sort of mathematical version of cluster analysis. This was 1854, where cluster analysis was really introduced in anthropology in the 1930s or so. And so this notion of using mapping abstraction as a tool to help us understand much more complex organisms, figures, environments, right, all is sort of very folded into the architectural consciousness. But then, of course, there's George Box's question about what are models. That is his famous phrase, all models are wrong, but some are useful. In particular, the question of interest is really, is the model illuminating and useful? We're also reminded of the fable that the Borges fable about the city or the empire that basically tried to create so developed in cartography, they try to create a map or a one-to-one, right, sort of simulacra of the empire itself.
So we talk about information in a more analog format, and so in the digital. Today, the way we engage with the information is a little different. It's not the information or the pattern or the images probably not designed for human to see, but becomes a signal to activate the autonomous agent system to be able to respond to the certain information that has been embedded into different images. So So the human vision is gradually being replaced by this machine vision, becomes how we perceive the world. And then seeing is no longer as important as before, but instead of seeing is substituted by this filtering or deciphering or this pattern recognition. And so the rise of digital media has led us to the simulated reality, as John Baudrillard described in Simulacra and Simulation. We no longer experience the world in reality. Instead, we experience everything through media representation, and the transition to this transition to digital involves 4 stages. The first is reflection. You have a digital version of object, like a photo. And then the second is you have a caption on the images to start to give in the information to transform the meaning to another meaning. Depends on how the author decipher these images or interpret the images. And the third is you have started this kind of replica of the original, and then the original start to disappear in this process of transformation. And so it's pure simulacra. You have a digital replica of original, but the original is completely disappear from here. The physical existence is being eliminated by this digital transformation. And so, like in the digital modeling software, we have we are pursuing the kind of realism in all kind of rendering, and then so we do this layering different information to be able to replicate the real, and then but this effort of pursuing the real in the digitals becomes a new materials that can further be printed out as NVRDB's project platform to becomes another new materials has a original physical quality, but in the same time it's a new kind of materials that can create new spatial reality. And so now I'm going to talk about the theory of sign, and then St. Charles Peirce's theory of sign is a great example of question of about this relationship between language, images, and meaning. And in the theory of semiotic, there's a signifier and signifier. The signifier is the physical existence, like image, sound. And then, for example, when you hear apple, you probably have an apple in the mind, but for the other person, probably imagine apple in different way. And then, but today, Apple probably becomes a sign of the Apple, the product, the company. And then the Apple becomes, their product becomes a system of objects that represent another cultural, like socially construct cultural meaning for most of the people. And then, but in Charles' version, he further proposed another way to see this sign, like signifier and signifier. So he introduced the interpretant that is it's like a law of observer. It depends on how you perceive the information with your background knowledge in different contexts. The meaning might changes. And so interpretation, the human cognitive response to the familiar pattern really common to see, and like we imagine the shape from the cloud, or we see the human face in different objects, and then this kind of familiarity of from your experience, you can construct a meaning based on your past experience, and this is highly like culturally constructed. And so for the machine, probably because of the training, the inadequate of the training data set, or so the human face, like we can easily recognize, probably is difficult for machine. But I feel that is where the creativity comes from. Like we have the ability to be able to imagine, and then like this is just a research to show that this illusory face are most likely to be perceived as male than female. I just want to talk about maybe the bias is not fully in the data set, but the bias is already in our culture. Like this is really cultural based. How we see the images maybe it's not too much about how we label, but just this bias that's the real reality. And then so the meaning of image, form, and language are continuously quivering like a quantum physics. The state of the quantum physics is only fixed when it's observed. So observer is really critical role in this process of recognizing the pattern to be able to see and think.
It's also helpful at this time to also kind of think about the machine learning models that we're using today for computer vision. And when bringing back in this particular study the Rorschach test, right, which was originally used as a sort of projective psychological test, right, to in a way categorize people's personalities. And this was actually essentially tested against a series of machine learning models to see both how the models performed, but also probably their inherent biases, and what they saw, right, in these intentionally abstract figures. Many of these are warplanes. So in card one, you see warplanes. But this kind of brings back a sort of discussion that's related to the famous Chinese room thought experiments published by John Searle in 1980. And this is a really interesting kind of thing to consider, essentially, that if you have an instruction set large enough, the person in the room can actually feasibly respond to Chinese queries without actually knowing the language in a way. I've heard of different variations of this Chinese room. The one that I know is actually called the monkey in the room, and the monkey sits in the room with 5,000 or 6,000, unique Chinese characters, and the arrangements and their meaning is actually derived from the person who's actually viewing the completed poem, right? And actually, a poem came up earlier in one of these discussions. So the poem actually, this is a very good example. I actually found this. This is the Chinese Cultural Center, Luxembourg, published this 13 translations of Lu Cai, which is a very famous poem by Wang Wei, which is who was a Tang Dynasty poet. And this is a sort of very common sort of Chinese poem that we learn in our grade school. I'll just maybe read it briefly. 空山不见人，但闻人语响。返景入深林，复照青苔上。And we learned this in grade school because this is these poems have multiple interpretations, and even in our textbooks, this simple poem will have 10 pages of annotations to kind of unpack its meanings. So the same website actually posts 13 different translations of the same poem, right, from Chinese to English, right? So there are all these sort of different, let's say, kind of territories of how you might interpret it depending on context. And I think context is the thing that is most important, that probably starts to differentiate some of the notions of computation and big data from before and to kind of where we are now, because the models start to become much more contextual and context aware.
So when objects are designed specifically for machine, the meaning of form is unknown. The pattern is unrecognizable for human. So these are the like satellite collaboration, collaborating images for satellites to locate their position related to the Earth, to be able to create a seamless images of the Earth. And then so I just start to going back to the discussion about how machines see this and how it's different from human can help us in the design process. And so this search engine, like we all know, like Google, is the way we find the precedent or reference when we design a building. And then, but for me, it's more like a filtering machine more than a searching machine. And just for the search idea of search, I imagine seeing all the possible results from the input text. But I feel this platform is more like a filtering. Things are categorized by their time, location, relevance, or type. And then even in ArcData, maybe by different program, different where the building was built, and then by the floor areas. So it seems like you have freedom of choice, but actually you are inside this predefined boundary to search for a new idea. And so it filters and recommend new idea for you, but in the end it ends up to in a visual loop to only see the same content over and over, especially in the Pinterest. And so sorry, there was a long introduction for this small plugin I made, and then a lot of tool or small instrument I made is like maybe useless for most of people, but it's kind of the reflection of my reflection of design to rethink about how we design. And so this is a plugin that can apply to different modeling software, and then it analyzes your 3D sketch, your 3D model, and then in a real time to provide you a similar images on the bottom left. And then you can decide whether to sample the texture or not to further influence how the machine see your geometry or see your design. And then you get the new images. And then so I think I was thinking this as a way to fast design to get an idea, to get different design options. And so it's like this: you capture your 2D capture 2D images of your 3D model and analyze by different like filters, and then show you the similar images. And it becomes a continuous conversation between human and machine during this process. So these are like some experiment I did with students. So each of the model is model finish and render within 30 minutes. But in this case, the geometry of the form, it doesn't have any meaning, but it's just a representation of all the images they have seen. And then this was before generative AI. There's nothing generated. Everything is human labor models, and then human generated. Yeah, just like all the design office. And then so this is the second version of it, just a standalone software to continue to explore these ideas. And so the second part is about human perception and agents.
So we're gonna sort of as a parallel. I think I was actually just in Singapore earlier this week before coming here, and this is Nedcon's sort of facade installation on the Marina Bay Sands, which is basically a low-tech kinetic installation that actually reflects the sort of air patterns and the wind that is blowing upon it, and sort of uncovers these sorts of hidden things. Another present, of course, is White Noise, White Light by Howard Layun for the 2004 Athens Olympics. And so the project I'm introducing here is called Latent Escapes. This was a sort of semi-permanent landscape installation at the Radcliffe Institute at Harvard University. Of course, we sort of call it interactive media, lightscape, also kinetic because of the movement. So a lot of the inspiration originally came from both, kind of what you saw in terms of, sound a little what you saw in terms of having something physical react to the environment in some way, but also wanted to kind of layer in some form of data, right? Some form of data in the background. And so that's kind of where at night, the landscape installation sort of entirely lights up. We actually have a fluid dynamic simulation running across basically the virtual surface of the park that actually is sort of actuated. There's several background animations that start to kind of use the color and the sort of very slow waving flow to represent air direction, wind speed, humidity, and temperature. But then when people traverse through the landscape, they trigger, there's a series of tripwire sensors implanted throughout the park so that when they walk by it, lets go of this sort of burst of light. And so part of this is also wanting to kind of maybe think about the larger environment and how media comes into our larger environments and be in the background. I mean, we're sort of very used to interfacing with everything through our phones and getting temperature and these things. And I think this is kind of a more sort of quiet or subdued, but background way of kind of conveying that information. So there's sort of some technological sort of framework. We're using Arduinos, Raspberry Pis, sort of headless computer with actually an NVIDIA GPU, a very old one back then. And essentially, these sort of tripwire sensors that we're using that actually usually is used in garages in the US. So this kind of larger scale installation, and these are just some photos, 1,600 LEDs that I found a manufacturer in Shenzhen, of course, of all places, to custom make them to the lengths that we wanted them to have sort of longer runs. And just to be able to actually sort of install them, as well as a custom GUI that we developed for all the different kind of parameters that drives the overall simulation, right? So this is sort of an idea of a simulation converted into media, but also combined and imbued right into a sort of physical environment with both digital and physical, tangible kind of reactions. And this was included in a Berkhauser publication. A sort of second, smaller, shorter version of this project is called Intrascapes. This was a sort of mobile, portable version of that, similar framework, except for one thing that we changed in this, and you'll kind of see it here a little bit in the interaction, is instead of tripwire sensors that were positioned kind of located, we're actually just using infrared cameras to track people's occupation. As they sort of traverse these sort of smaller installations. Now, this was actually designed for two different contexts. One, the Acadia conference in Cincinnati, so sort of gallery situation. Of course, fabrications involved, all these sorts of things, shipping, and then also for a small plaza outdoors in Georgetown, Washington, D.C. And so the camera is sort of mounted as an overhead with an overlay of our positioning, as well as the similar interface that controls both the color, intensity of the LEDs. One thing we noticed, especially for more high-level interactive, more crowd interactive installations, is that there's a certain point where too many people actually start to overwhelm the system because the system is trying to react at the same time. So we started actually putting in noise generators and different things to actually, let's say, kind of vary the sort of background animation. So these are just some very quick. And I'll end this little segment with just saying, like, these sort of two projects are sort of humans in real environments and the sensing of their movement, but not necessarily their intention or emotional states. And this is kind of where Jimmy comes in.
And then I want to go back to talk about representation, and architecture heavily relies on techniques like collage or projection. And then so these are the first photo that was taken like in 1826, and then the other is the noise that you can see on all the diffusion model that is the images generated. And then I think architecture is a profession that relies a lot about this image making and storytelling through the images, and then we kind of the emergence of the generative AI bring kind of intensify the focus even more on this image making production. And then I think representation as a design, for me, representation is kind of a design tool that we use it to filter out the information to convey the story we try to talk. But looking at these AI generated images, something that intrigued me is the absence of a human figure in these generative images, or even you can see some of the human figure on the drawing, but human figure here are more like often rendered really in an absurd way, becomes a background or foreground alongside with this generated architecture object on the images. And I think human figure was used in a way to convey the story in the painting. We can see, you can follow the gesture of the human or the eye gaze to see all those interactions, to know the space, to know how human could perceive these spatial qualities. And we used to produce a lot of digital collage in the architecture design before this generative AI. I think most of us probably have seen this figure appear in different competitions or rendering from students, and the digital presence of this human agent or this human figure kind of live across the space and time. And then we also have this very stylized sauna figure. You can see people using it in all different drawings. And unlike Le Corbusier's figure as a measuring unit to see the scale of space, contemporary figures are more like an agents to mislead the audience to misread the information. And then I think the movement of human can further expand to be a way we annulate, we capture those spatial qualities or more emotional qualities through this human interaction in the space. And yeah, and then with today's technology, we have all sorts of data about humans' behavior in the space, and then we use it as an evaluation metric to design a space that is probably more sustainable or more comfortable. But I was thinking if there's another way we can create, we can use we can train different agents to create space beyond this only comfortable or maybe it's more phenomenological perception. We can embed emotion into the human agent, so go beyond this digital, really technical simulation. Like this kind of simulation, similar crowd behavior in the space, and then human being trained as a full assistant to be able to optimize the building performance. But I was thinking, what are the other way we can embed the perception, the human perception into the space. So this is another small platform I try to experiment to be able. But this tool is not that useful because all the we have bias as a human. So this tool we train. The idea was to train different agents, so we kind of anticipate what kind of user will use the space, and then we train those agents to put in a space. So maybe you have 10 or 20 different brands for agents, and then each agent will react to the same design different way. And you can determine to change your design based on what kind of user you want to introduce to the space. I feel this is really like a traditional way of design. We also design based on the user's demand for a space. And then, but I think this real-time interaction can give another, can become another factor to influence how we think about design. And so we ask students to go to the public space to observe human behavior. And so none of these human agents really useful as a design tools, but they are kind of how those students think about how these are trained based on how they observe a human. So it's highly biased. So all agents behave a different way. And then, but I think this is what go back to the discussion about reality. Reality is all about this by a socially construct meaning. So even this, I feel even this inaccurate model can be a way for us to evaluate design because yeah. And next we'll talk about language and form. And so Alan Turing and Klaus Shannon, they kind of work in different way to think about this information. One works on the decoding information, and then the others work on the encoding information. How do we reduce the information loss during this transferring process? And so, in order to transfer information in different space, this is like we have a key to decipher the information in different way, and so this is an example of the barcode. You can see this paper is well designed for machine to see. So every part of pattern in the image has a specific meaning to what signs for the camera to locate the position, signs for to know the direction of the images, and then the QR code is able to store more information than the barcode with more complex design. And then, but this kind of using a pattern or using a form as a way to store information or transfer the information was already exists in the ancient society. Like stone and token was used as accounting tools, and then so each of the shape of a stone is kind of has a meaning on itself, and then the stone and then then the whole created by stone becomes a system that communicated a particular information. And the other is this is a like experiment from linguistic experiment, Buba and Kiki, and then when you hear this sound of Buba, you like from research shows human always related to this sound, to the geometry or to the form like this. When you hear Kiki, you see you ultimately find something that is spiky, and then this kind of relationship between the sound or this acoustic relationship with the phone is also interesting to think about how we describe architecture, and then can we perceive architecture in this way instead of can we identify the style with the sound or with other kind of annotation system to be able to give it more information to the same objects. And then we all know large language model based on this transformer attention is all you need, and it has the ability to self-reference to the context to know to detect. So the meaning is more comprehensive, and this becomes where the illusion starts to emerge that we think there's an intelligence inside this machine. And so, but in architecture, like how do we describe form? How do we know this? Like in a school or in a office, we often have this kind of discussion. Can you change this curve a little bit? How much is a little bit? And then, but we cannot really use scientific way to describe this phenomena. These really subtle changes only can be. Only gifted architect can be able to create something that is like really attached to the emotion. And then, but I think with this AI tool, we can start to think about what are the different ways to describe architecture, and then can we try to embed this kind of perceptual, emotional characteristic to the form.
So I see this slide has resonated with a lot of people in the audience. So we've been affirmed before. But anyways, so this is sort of a lead-in. I'll sort of talk about a lead into the third project that Jimmy's worked on. And so this is some student work from the University of Florida, which in the sort of first year we go through a kind of very classical progression of the cube project we call the matrix, and eventually the room and garden. Because the cube is a sort of standard, 9 square grid exercise with mass, void, solid, as well as linear elements, planar elements. That sort of compositional introduction to both form and space. Matrix is much more of a sort of mapping exercise in some ways of converting things into abstract relationships and drawing those abstract relationships, whereas room and garden sort of combines them together. Now these types of projects are often the kind of foundational training for architects in many ways. We do actually oftentimes use 2D imagery as a sort of beginning point. In this case, Diebenkorn, right, kind of color field images were sort of grafted into Peter Eisenman House 4 floor plans, right? Trying to negotiate the sort of very hard thresholds versus the very soft kind of boundaries. And so you'll see also some sort of color field drawings and explorations on the top that eventually get kind of developed into these three-dimensional constructs that the students actually initially don't necessarily have, very strong, let's say, meaning behind them, right? But in the subsequent year, we introduce a project that's sort of colloquially been referred to as door, window, stair, that actually really uses, all the studios use different things, but they also come from the sort of realm of cultural artifacts, film, literature, choreography, music, paintings. And so this is one of mine. My personal favorite is Rondo La Run, a sort of very cult German indie film. And these are sort of interpreted into formal and sort of drawings as mappings of projects. At the same time, throughout this process, usually, right, and we had this discussion with Sarah earlier about, let's say, the productivity of diffusion models in the sort of design, generation, and iteration phase, where the top is actually a student who drew this, and then this is around the time, 2020, when DALL-E 2 started to come, and you just started to try, well, if we take this part of what they did, then is the education experience really about me or the student doing 5 of these, or is it really actually, like in the Chinese room, being able to recognize patterns and things that are meaningful and assigning meaning to those patterns, whether they're 2.5D or 3-dimensional?
So we use this studio project from University of Florida is start to do this experiment to see can we create a customized AI that to be able to instead of regenerating the whole model all the time, can we modify by the parts in every iterations, and based on the designer's preference, so the design can be a continuation of the continuous iteration of the same concept. And then, so this is still work in progress. And then, but now we have a generator that randomize these geometries in a 3D space, and then to create something resemble to the doors, stairs, and windows project in the design studios. And then, so in the data, first we create a 3D data set from the generator. We have 3 different design, and then so from this generator, and then we slice these 10 design into parts based on this grid like voxel systems, and then this is so the resolution of the grid doesn't really matter. That can be determined by the designer. So after this process, we kind of lay out all the parts, and then these are all the parts. We have around 1369 parts that is being collected, and then we, as students from University of Florida, start to label the design. We have 2 ways to collect this human feedback, designer's feedback to the. And the first is we have a eye tracking device that track where the the design where the designer is looking at the geometry when they see the question prompt on the interface. This is web-based interface, and the other is they can select. So these two just to see whether the intuition will affect how we label, because we also record the time code on this, so we can know how long does it take for a student to label one term to a geometry, and then so these are kind of collect two resolution of the label to the 3D data set.
Just a quick interjection on labeling, and a lot of this actually comes from the sort of one of our earliest design exercises that actually strongly related to Richard Serra's verb list, 1967, who passed away earlier this year, rest in peace. But this is kind of part of the training to develop an architectural vocabulary, right, that both these sort of incoming students and faculty and just going to be in part of the sort of profession to start to sort of be able to communicate, right? And I think part of that, this sort of experiment was actually to see both simultaneously, and you can kind of talk about this, simultaneously to see which parts of this physical model do the students themselves are most interested in as they're kind of trying to interpret, interrogate, and kind of understand, right, this sort of 3D model, but also at the same time, what would they call it, right? And these are the kind of two linkages between those two sides.
Yeah, a lot of vocabulary or description in architecture is sometimes really ambiguous. You have one term that can describe different geometry when the context change. So, so in this like this kind of design, you probably have a similar geometry that, but you student label differently when it's being placed next to different kind of geometry on the side. So for the data set, we have we have five. We have students who have 5 design, and the other 5 is on labels, and then we these are the collect data with. So first test we just use a different description to a student to label, and then so we use a self-organizing map to reorganize this geometry based on the similarity of form, and then just to label those unlabeled geometry based on the how close they next to those labeled geometry, and then you can see some of the geometry probably have more than two tags, or more, at least each one have at least 2 different description to describe, and yeah, so these are the so current stage right now we have created something like a larger library of geometry that's labeled by the students' feedback, and then also the data set was enlarged based on this possibility of labeling, and then so here we have this is demos to show. As a designer, you can come in, start to change those geometry, and then to decide to choose from this larger library. But once you have enough data set, it's easy to be able to transfer to the natural language input to control this design.
And this is also just sort of leading, going back to the discussion we had earlier with Sarah, especially in a sort of educational context. How do we use generative AI, especially in this case, when in the past we might have said, oh, go and draw 5 different diagrams of something, and now if the student actually just generated one and is able to generate variations, then the discussion was going back to actually it's much more about recognizing and curation, right? What are the criteria you're setting out for yourself? Now, of course, these are kind of more abstract in a sort of fundamental design level, but I've also kind of started trying to do it more comprehensively in the studio in the upper level, where essentially the generative AI is applied to a multitude of different situations, both, of course, the early schematic massing model in particular, in an urban context, in this case New York City, but also letting them test and try out different viewpoints. So sometimes aerials, sometimes details, sometimes elevations, all these sorts of things. But in particular, the ones that are actually quite interesting are the ones that actually try to do it with a conceptual sketch, right? Not necessarily a precise massing model, but something that is maybe a bit more idea generative as opposed to a sort of form derivative or form driven as an end result. But educationally, I think this really goes, actually has its roots in the Beaux-Arts analytique, which are effectively multimodal, multi-scalar drawings that combine, and of course this is because of the analog era, you kind of had to have a certain efficiency of how you draw things and combine things as a sort of representational technique. But these all have multiple kind of codified design problems living inside them, dealing with the basic elements of structure, proportion, composition, but eventually through the shading, materiality, and light and shadow, and a solid and void. And so these sort of image grid experiments incorporating generative AI are actually trying to get the students to realize and sort of recognize these relationships in a sort of cross-scalar kind of way. Now, of course, earlier today we had kind of talked about realities and going back into the discussion through model simulations as sort of abstract, imprecise yet useful representations of reality. But of course, as an architect, I still sort of aspire and want to work back into the physical reality. And tolerances and imprecisions are sort of inseparable parts of this physical reality, and sort of reality is, by definition, quite messy. So I'll show two small projects that are kind of related to this. And so with my design collaborator, Gregory Spall at American University Sharjah, we've been sort of working with robotic tube bending with some sort of simple experiments. Sort of at first, this is sort of a small coffee table, a sculpture, sort of reinterpretation of Chinese knots into these metal forms. And of course, we want to start to kind of make larger assemblies and constructs. And so this is kind of one of the things that came back is to kind of use an augmented reality interface to kind of assist in this process, except we're incorporating the robotic sort of, the precision of the robotic kind of fabrication assembly into the process. So this is a working off of the Hologram plugin, as well as Grasshopper, to have essentially kind of a live design model that actually projects the bending geometry into the workspace as the sort of the robot is actually working. And in some way, it serves as a sort of sanity check, essentially, for what we think the robot should be doing. The program actually is very, very simple, and so we're comfortable kind of being in the same workspace as the robot as it's kind of working. But oftentimes, it's actually useful to know what it wants to do, and you can kind of do a real-time, almost sort of quality check on the process. And so it's a sort of augmented reality interface that's working with a sort of digital fabrication sort of method that is precise, but we've found, at times, having it can be a very, very useful tool for knowing what is to come and what the robot is going to do. Now, this sort of whole kind of assembly process also goes into actually parts of error correction, because we had sort of elements that were long enough that they would cantilever so far out that it overcomes the frictional grip of our gripper. And so we actually had to use, at certain points, use the augmented reality kind of projection to sort of recorrect some of these sort of fabrication elements, as well as cases where fabrication elements almost are going to run into the wrist as well. Now, eventually, of course, assembly comes in, and this is still working off of, in this case, twin build, but now they've all been integrated into one platform. The sort of assembly side of things with the sort of centerline projections in space, which looks like spaghetti. And you can see Greg there grimacing pretty hard. And of course, to kind of put these together, there's sort of sketches and developing a taxonomy of joints to be able to create all these sort of crossings and jigs for drilling the joints together, as well as a very, very super high-tech Sharpie in the background. And so the sort of completed sort of artifact looks like this, and it's, while it was on display, you can see the QR codes. We invited people to actually wear the HoloLens and kind of experience the thing in the installation. in a sort of mixed reality mode, so you simultaneously saw the physical object, but also a sort of projection of the other half. In this case, in particular, we had learned the lessons we wanted from this particular experiment, so instead of building the full thing, we actually did a different iteration. And of course, I here just wanted to acknowledge Greg and last year when I was here for 3 weeks, this was the sort of project. I was at AUS for several weeks, and this was the project that came out of some of this collaboration. And finally, on the other end of the spectrum, this actually was just completed right before I had to go on a study abroad trip earlier this a month ago. So. Previous project was using augmented reality with precision robotic fabrication. This is intentionally low-tech, imprecise analog fabrication methods with essentially AR-assisted craft assembly. And we're sort of designed to incorporate in precision. This was actually an independent study project just done with sort of 4 students, sort of on and off, but most of the work was sort of completed in like 4 days or so. The design was sort of slightly premeditated, but what was also kind of interesting is that one of the things that's really nice about this workflow is that it allows you to actually make very quick sort of on-site decisions and adjustments to design and project them into the space just to see and actually kind of try to correlate the 2 models. Ultimately, this was sort of voted or sort of mutually agreed by the students of what to do. What you're seeing right now is a very, very expensive cigarette lighter. Just kidding. So in Florida and in the US, they have a lot of boats that in the winter they need to store, and so they use what's basically marine grade shrink wrap, right? And marine grade shrink wrap is essentially this plastic that shrinks, I think, like up to 40% when you heat it. And so you can actually tension it around a lot of sort of rigid geometries and just let it find its minimal surface. So we're sort of incorporating that into the sort of middle section. This sort of final section here that you see is essentially the pinup surface using very cheap plumber's strapping that is used to kind of hang plumbing from the ceiling. And it becomes a sort of open lattice magnetic surface that is also kind of actually mapped to typical paper sizes and becomes a sort of pinup surface for the students in the studio. So we're going to use this. And the choice of materials, and actually there's a sort of bench portion that actually includes basically reclaimed wood from discarded, there's the driver, with discarded bed slats, right? And so the sort of notion of all the materials, the technology is actually intentionally kept like almost as low tech as possible in a way to say, well, I think the largest potential of this technology is actually to democratize all these sort of crafts and techniques, but also enable the sort of construction of unique and interesting geometries like this. So just some detailed shots. Because I had to leave, we haven't fully figured out all the sort of lighting portions of it, but I think part of the intent is actually for this to be a low-level interactive sort of lighting sequence at night that will sort of respond to ambient noise and human occupation to some degree. I'd just like to acknowledge the 4 students here. Thank you.
Thank you, Jimmy and Lisu, for this talk. It's very interesting and stereoscopic, seeing like both of your works kind of like interwoven into each other. So like it's kind of like becomes this like multivariate thing that we can now start like unpacking, because it's super rich. Like we're talking about how humans make meaning, semiotic, sensing environments, representation, labeling, making, all of these aspects. So I'm sure there are many questions from the audience. Okay, well, then we are collecting questions. I might start with one. It might be a bit of a stretch, but let's see how it goes. So, like, I think something that I was thinking a lot, especially in the beginning of your presentation, when you were showing different kind of approaches, one more with the semiosis, and then with this kind of digital beat field or something like this that reacts to you. I was thinking how like this is, how this talks a bit about like two almost complementary but also contradicting attitudes towards computing and how we see the world through it. So on one hand, this kind of beautiful sensorial or like sensitive landscape starts to pose the question of like looking at our environments as something that react to us, that kind of knows that we are there. Like we go through like a forest and it knows that we are going through it, right? And they react to us with colors or sounds and this. And we can do this because we can work with like sensors and actuators and microprocessors and all of these kind of things. And then on the other hand, there is this kind of computing where we have these kind of recognition techniques where we say, okay, like this is an apple, this is a brick, right? And we classify things and we tell them what they are, and they cannot do anything about it. Like the brick cannot say I'm a butterfly, right? Like it's going one way, it's not reactive at all. And so I was interested in this kind of like, discussing maybe this role of code, how like maybe code, especially because it kind of suspends meaning as we are coding, it allows us to develop some sort of meaningful connection to the world.
Yeah. Sorry. Well, I think it's a really good question because, you know, of course, especially in the case of the landscape installation, the introduction is hard-coded, right? It's something that we're fine-tuning all the time, especially, you know, with a larger field, you have less, let's say, people, actors traversing it. And so there's a certain level of control you have over the simulation. Whereas, you know, and this is why I think, like, to a degree, what Jimmy was doing was really interesting because we had actually, with the physical installations, we had a certain difficulty in terms of actually trying to simulate what would it be like when we deploy it, right? And that's always and actually, you know, thinking about, you know, servers and like game releases, right? You know, games, the servers get crashed, right? There's actually sometimes, you know, in those situations, there was not an easy way for us to simulate what if we had 50 people walking through us at the same time, what kind of settings do we need, right? And like so in the install of the installation, actually, even for the first couple of days, we actually had to do a lot of observation to fine-tune those aspects and say, okay, if it's just 3 people, this is the state we're in. If it's 50 people, then we need to change our trigger kind of activation modes and things like that, right? And I think this goes back into both, you know, kind of the notions of both like digital twins, crowd simulations, Omniverse, that it becomes the sort of the digital surrogate that's actually able to help us simulate these sort of physical reactions. And I think that's the most kind of, at least for me, the part that I see really the potential of that thing going the entire loop and coming back and helping us in these sort of situations.
And then for me, I think like in design, we have all kind of limitations, especially when you really need to realize the building. And then I feel those kind of material resistance is something that increase the creativity in the design process. And then I see these material resistance also exists in the digital realm. And even if I work on most of my works on a digital platform, but I will just try to find what are these digital material resistance that can create. Maybe it's not really direct response to what the reality condition is, but it's response to the digital constraint or digital reality that becomes another agency to be more to stimulate your creativity in the design process. And I think that's something interesting for me.
But that being said, I think like the reason this sort of thread, not only ours, but even earlier with UNP, that like the thread of like the general intelligence, right? That I think instead of, in a sort of ideal scenario, instead of like trying to go through and hard code everything, you actually want something that's adaptive in that sense, right? And I think that's what the kind of suggestion of like something that could react to game engine, something that could react to different situations and kind of exhibit that level of generality, I think would be the best sort of future.
Yeah. I mean, are there more questions in the meantime from the audience?
Thanks very much for your talk. It's really interesting. I guess one question maybe more on like the site, because you showed a lot of kind of work that was obviously involving your teaching practice, and so you mentioned at one point this idea of the AI and the options being able to maybe replace the idea of asking the student to go away and draw something 5 times. Obviously, as an act, it's maybe quite a different thing. So, but it was also really interesting to see the systems you're using for almost like crowdsourcing the kind of like feedback on the students and their own design works with their peers. And so I was just wondering if you had if you as educators have kind of observed any changes in the way that your students design, because you're obviously talking about, say, undergraduate students as well, maybe students doing more foundational knowledge. Do you find that those techniques have like changed the way that they work? Is that something that has kind of made like a big impact in the way that they approach things? Because obviously we're talking about AI as like researchers are working at a high level, but for students who are coming into the industry or into the kind of educational system for the first time, that idea of the foundational versus the experimental is always like a kind of boundary. So I was just interested what your experience of doing these kind of systems and techniques, how would that change things? Is it good? Is it bad? Is it a new type of student that emerges from that?
I wouldn't say that I would, let's say, pass a value judgment on the good or bad, just different, right? And I think, well, one of the things is the media side of it, which is kind of really interesting because, so at least our institution, every year there's a student publication, self-organized, so it's actually not curated by faculty at all, even though sometimes it should. But the students self-organized, and the publication kind of collects student work in a sort of, in loose way, and that kind of somehow becomes the holy grail for the following year, because they say, oh, right, this is what we're supposed to do, and this sort of, kind of trajectory, and I don't know, SciArc, BPro, right, all have similar aspects of the show being the spectacle, and everyone coming to kind of think about, oh, what should I do in the future? I think it's great in the sense of opening possibilities in some ways, but it also, if the students themselves are too focused on the purely formal or visual aspects of the work, then they don't read deeper into the kind of meaning and understanding of things, right? And I think that's kind of what, to a degree, Jimmy's experiment of, both from our end, our discussion about architecture vocabulary, where it goes into, but then kind of almost testing to see how much of that, wouldn't say worked or not, but what was their kind of perception or viewpoint of the things they were reacting to in a way. Yeah. So, but the sort of question about me and also goes back to, Pinterest, right? Because Pinterest is, and very specifically, nowadays, when I take students to go to like firm tours in New York, SOM, these places, they actually tell the students, don't become a Pinterest designer, right? Like you don't want to be someone who only relies on that sort of imagery, right? And that's the side, I think, of the generative AI that we, or educators and the students also have to grapple with in terms of like not being overly seduced by the imagery, but actually understanding how to work with it more. In a sort of different parallel, the analog parallel of Sarah's kind of AI sketches of Rome is actually, our students still do literal sketches, right? But the sketches are not pictures, they're analytical sketches, right? And so part of the sort of experiment actually that I usually do is both like not only kind of ask the students to draw an object or a building that they're seeing, but also being able to draw it blind, right? Like take the object away, or they turn their heads, look the other way, and try to reconstruct it from memory, because when they're reconstructing the drawing from memory, that actually means they understood the sort of structures of the project. Yeah.
Thank you. I've seen 2 more questions. First, I'm going here.
Okay, I'm not a designer, so to make it clear. But I'm coming here, I'm looking for some clue about how the AI could enhance the design process. So from what I heard in the last 2 days is that still AI is used at the periphery of the design process, using AI to assist the designers to do the work. How far away from the point that AI can actually do the design itself, actually doing it better than humans? Now, this is a little tricky here. It's like, how do you define a better design, right? I think AI, if you work with the AI, particularly reinforcement learning AI, you have to tell them what is good. So in the design world, how do we define that criteria so that AI knows, you have trained the AI in a way they know what is good and what is innovative, what is better. So I just wanted you to get your thoughts on that.
You want to take that?
Yeah. I guess that is also a question I have as a designer. That's why I'm trying to investigate what are the answers. And then I guess as a designer, that my experience in maybe in a professional practice is more like all the competition, international competition, we try to do maybe the winning projects, not the design that is best in terms of the performance, or maybe it's not most reasonable, but maybe it's innovative in a way that the jury like, but I don't know what is the evaluation metric, but I guess this kind of, I think design, and I don't know, I feel it's really abstract. That's why I try to introduce other factors like emotions or other way to evaluate the design with these AI tools. And then because, like you said, AI is like optimize the result, we need to give the answer. I guess like through the unsupervised learning of different way to embed information into the model that can become something. I guess that's the moment when you lose the control of the model. That's where the creativity starts to emerge, because this interaction between the machine and human is where the innovative result will come out. But this is not like, I guess this is still really conventional way of thinking about the design. I still believe this kind of human input in the design process.
I mean, I think one part of also, we saw in Andrew's presentation and Fred's yesterday, that kind of start to kind of point the way a little bit, is also the kind of larger curation and collection of data that can be usefully trained, and I think, in other forms this has been discussed, because for most of the building industry, it benefits the companies to kind of keep this information proprietary, both for financial but also sometimes security reasons, right? And that's why I know Fred had to model, I don't know, had 600 of the Swiss competition entries, right, in a sort of manual sort of way. I think part of that is really reliant on this kind of collective data set somehow, right? I don't know if it's the governments or the industries coming together to create this. That's actually a usable and trainable data set to actually drill down into these sort of more finer aspects of the data that's necessary to train meaningful, let's say, right, and useful models that have like broader general impact.
I think, Katrin, you raised your hand earlier for a question.
Yeah, I don't know if I will be able to formulate it, but yeah, first thank you for the nice presentation. I really like many parts of it, but intriguing is this kind of like having the students learn the architectural language and at the same time giving them the opportunity to label their own kind of creations, so to say. And I had to, it came to my mind this kind of, I don't know if you remember that, but there was this bullshit generator.
Landscape bullshit generator.
Landscape.
Yeah.
Exactly. Which then was hijacked by the architects as well. And I'm wondering, like, what can you also bring in this kind of more humorous aspect to, like, or do you already have some sort of kind of maybe feedback also from the students, also to not, to bring in, to make, because sometimes it's really hard to to describe what we're doing. No?
Yeah.
So, and then maybe this can be also like unlocked by from that perspective.
Yeah, and that's a very good point, and I think that's kind of what characterizes at least the intent behind using a cultural artifact is that it's a more of an emotional state, right? Emotional state that everyone has different interpretations of. And I think the notion that the students can really carry that strong emotion into design, because if we start on the other end of the spectrum of let's say practicality and these sorts of things, then the students actually really have a difficult time really getting into a project, right? So that's why, like in the sort of early foundational projects, they are very personal, narratives, right? And so storytelling. They're very personal spatial narratives that unfold from the students' very own personal kind of point of view. And we're kind of, in some ways, being invited into that world, right? And it's that sort of repetition of practice that eventually allows them to basically kind of construct a strong conceptual narrative for projects that can then absorb the technicalities and the requirements and the regulations that a building requires. And so I think, like, at least pedagogically, that's the kind of direction that we move. But it's also like, the students get kind of really excited about those things because they kind of have somehow, right, more ownership over it because of that authorship and saying, whether it's coming from a film in my interpretation or whether it's they made something up, they've made, so there are different versions of where we go through a coded process. I said code in the sort of more instructional way, a coded process that gets them to a narrative, a story that they can then develop into spatial ideas. And so, that relationship between language, right, is here.
Adil?
Yeah, thanks a lot for your presentation. I mean, I know Lisu's work from before, and it's always nice to see it again, jog the memory a little. But I just wanted to say to this tool that you made, Jimmy, and this owl, I love it. I've never thought about a suggestion engine alongside 3D modeling. I think it's just fantastic. Where can I buy it? Or can I just take it? And I'm also curious, is it still under development? What is the database behind it? What kind of objects were you choosing, or is it real time as well? I would just like to get to the mechanics a little bit more.
Yeah, it is connected to the Google search API, and then it just every 5 seconds show you different images based on your screenshot of the geometry. So it depends on how still analyze the geometry as a 2D images, but as you rotate or as you change the texture, the assumption was this kind of algorithm will be influenced by all the interaction you do to 3D models. And then even if you build Blender, you can create really realistic images. And then so even if you change your lighting, it also affect how the images will pop up. And then those are just a reflection of all the design experience I have in those kind of international competition or from the school. Like always, you get the Pinterest images from students. So I was initially kind of making fun of this kind of teaching pedagogical thinking about how we teach and how we can replace teacher. If you embedded ChatGPT inside, it makes maybe can start to critique your design and then give you the feedback and then
Now we have these diffusion model plugins in Blender or any of these, but this is just so much better because we get actual good stuff instead of kits. So I just found it fantastic. I just wanted to say that.
No, I just want to continue. I say this tool is useless because I found when people talking about AI, we're looking for one button that can generate multiple output, and then so this one just showing the reference, and then but you're still doing the modeling. But I feel currently, when we discuss about AI, we're always looking for the efficiency of getting the immediate output from AI, and I feel the the designer is kind of being removed from this process because of the discriminator to select. But I feel we can intervene this process in every part of the design design thinking, decision making.
Maybe to riff off of your response to Katrin regarding storytelling and this personal angle on student projects, but also on the comment we had earlier about like what is good architecture and can we make models to create good architecture. I was thinking of like the beginning of your presentation where you were speaking a lot about perception, like how we might think of perception as this like very personal, perhaps even subjective thing, but then there's something happening like communication or narratives, storytelling, and then this makes this kind of perceptive capacity something which might be interpersonal, also like both enabling a kind of a conditioning on one side, because once you have seen something it's hard to unsee it in that specific way, but then also it is also a allowance for something like a co-perception to happen, and I think this is where architecture comes in, or like the power of architecture comes in. So do narratives actually in the end matter? Like, and if this is the case, can we think of architecture as a kind of, or buildings as a kind of manifestation of these narratives that we tell ourselves? And if this is the case, then maybe if one would go a bit further, then maybe we can start differentiating between buildings as such and architecture as well, because like Abuba and Kiki buildings, you had them in your presentation, are they kind of like pre-existent in like some part of our brain? Or can architecture change what Buba and Kiki buildings are? And then if this is the case, can really, really good architecture, like exceptional architecture, become these kind of like turning points? So like a building might always be a Kiki or a Buba building, but like really, really good architecture is that moment where these kind of preconceived ways of looking at the world starts shifting.
Wow, that's a tough one. Well, okay. So of course there's the response about, let's say the sort of collective cultural shift of how the perception of something, right? The Eiffel Tower, right? Like, you know, was generally hated when it first came out, and now it's like the sort of loved kind of icon. And so I think those are things that sort of shift and change over time, over the sort of collective consciousness, right, of a society. And of course we know, right, you know, we have all the sort of different architectural movements, and, you know, even our traditional definitions of beauty have kind of shifted and changed throughout the centuries. So, but I think the thing here that is kind of most interesting is that, like, you know, buildings are always part of the larger discourse culturally, just because they sort of exist in the environment. And I think, you know, what is interesting is that, you know, earlier on, I think with Julius's work of monuments, right? The monuments were things that are actually put out in the public realm and always are there to either like generate discussion, right, or have discourse around things. And I think that's the part that, you know, if there is some kind of global discriminator or filter or curator of these things, then it is something that actually would, like our current models, be continually updated to reflect the sort of current, right, gestalt, let's say, you know.
One last question, just a curiosity. Have you tried with your students to use the 3D generative models like CSM or?
No, not yet.
Not yet.
Yes.
Are you planning on it?
They also do ask questions about, like, is this cheating? So there's a little bit of a psychological hurdle to get across. Thank you.
Right. Sure.
This is an amazing conversation. It's actually a simple question. I'm curious how, like, your students, or for both of you, like, react to this digital ecosystem. Like, do you know if AI explorations are task related to the courses, you know, to pass the assignment, to pass the test, the exam, or do you know if then, like, you're starting to see kind of broader use and students continue to sketch and to make models and make renderings and go back and forth between all of these?
In my case, especially with the sort of the upper level studios, it depends on the person. Yeah, some people really love it, and some people are uneasy with it. And I think there was an earlier kind of discussion about maybe that, especially when working with the generative image models, the most common feedback you get from the students is that I can't get it to do what I want it to do, right? They don't need to think of it. They should be more like, well, let's see what it generates and what you can interpret from it, and that's a much more kind of, let's say, positive way of thinking. But of course, with comfy UI and such, you can start to kind of close down using ControlNet to kind of constrain the outputs. So, but I think it's more just that they all need a dial that they're able to tweak to say, how much freedom am I allowing and where? And as long as that's there, then I think the sort of productive use of it as a sort of generative tool at many phases of the design process becomes much more kind of viable. But I think ultimately what gets confused, I think, is more, and that's why in the image grids earlier, there were a lot of hand sketches that were more just kind of design parties, because that's the core of the project, not the image, right? And I think in some ways the design party sketch is more important than the images. The images are kind of projecting realities into the future, but they have to have a very strong understanding of like what makes their particular project work conceptually more than anything else.
Yeah, I just want to add on a little bit on the talking about this topic, and then I feel a lot of architectural language only start to make sense when when students learns more about this vocabulary. When they first started, maybe in the first grade, when they start to using these tools, maybe they needed more like they needed less control on the object to looking for the result in order to understand what is a good way to describe architecture. And then as you get more educated in architecture, you start to talk it in the same language. And then this, I just want to reflect back to the discussion of architecture and building. I guess only for the people who doesn't have architecture background, building is architecture. But for architecture or architect designer or architect, they refuse these ideas of architecture is the building is
Capital A architecture.
Yeah, just like so. I guess
You led into something that I wanted to bring up, and I haven't had a good way of formulating the question yet, but it's been on my mind since Benjamin's talk yesterday. And he was also mentioning about the kind of languages that were being self-selected or formed in order to describe and to communicate within different builders and producers. What was a kind of cliff or a ridge or an edge or a bottleneck? It's kind of metaphors, formal metaphors. And I find it kind of interesting because, of course, these are really irrelevant to the actual model, to the computer model. If it's an unsupervised model in particular, the interpretant, if you want to use the Persian terminology, is not a language, but is not referencing into a not thought through language. It's thought through kind of affinity of something similar. So, like again with Fritz, the note SOMs, they're just somehow similar notes. They don't have to be explained. And so I was happy you said just now, they don't need to know what they want to do with it or make the computer do what they want to do with it. Actually, maybe it's to give up some of that authorial control, or give up some of that imposition of meaning, and to follow the way that the computer is thinking through it, follow the affinities that the computer is bringing out for you, particularly in these kind of unsupervised models. Which I believe the kind of Pinterest recommender was also a sort of unsupervised model, right? It's not looking at this looks like an apple, or this looks like a person, or this looks like deconstructivist, therefore I'm going to give you something from the library, right? It's pure similarity stories, right? So I don't know, I wanted to throw that out into this session. Not to discredit narrative in design, or narrative, or even formation of an architectural language, which we can use for discourse, but if you think there's a changing role maybe in terms of how we use technology and how we author with technology, are these sort of metaphorical or language-based or narrative-based approaches still kind of relevant, or are they becoming a choke point or a barrier or a way, something that actually disconnects you from your working process?
Yeah. Maybe a counter to that, and it's just like, a counter to that is like, I think that the profession is really, we are communicators and integrators, right? The sort of design and the drawing is actually just one part of the job, but you have to tell the story, right? And I think you can have the nicest renderings, but if you don't tell the story right, then the audience gets a completely different impression of things. And I think that's kind of common, let's say, in museums where you walk in and you say, oh, I see a square black canvas. What the hell, right? But then like once you kind of start to understand, then you understand the story behind it and its meaning and all these other things. So like, I think those are the kind of multiple layers of the cultural meanings of form, right? That we're all kind of trying to find ways to either tag, imbue, embed, right, and give meaning. But of course, the previous discussion about those tags and meanings actually being something shifting, right, because they change with the gestalt, and so that's the part that makes it more needing to be some kind of more, let's say, live consciousness that at least periodically updates those things.
Right. Thank you, Jimmy and Lisu.
Thank you.
This was a great discussion.